Yeah, what's up, brother and sister? How you doing, man? So, what's up, brother and sister? You know how we doing? We not waste no time. And distinctions guarantee. You know how we do it, right? We not waste no time. And distinctions guarantee. Okay. So, first and foremost, if you're new to my channel, go under there. You know what I'm saying? Click the like button, subscribe to my to my channel right here. You know what I'm saying? If you're new, okay, click the red button, and you can click under here and watch my music. You know what I'm saying? If you're into music, follow me on Instagram. Sometimes I don't put everything on YouTube, so you can follow Instagram. So let's not waste no time, and distinctions guaranteed. Now we got this question here. This is a video request from a lot of students. You know what I'm saying? So let's say question number 3. Which of the following equation is correct? So now you know what I say. 1 is correct, 2 is correct, 3 is correct. How did you know it, huh? How did you know that, boy? You're gonna have to work it out, okay? So now let me show you how to work this out. So first and foremost, before you start it, because some people don't know what is happening as far as exponential, okay? So let me explain to you like 3 minutes. No, 3 minutes is a lot, man. 1 minute. So now, look. Let's say A, B. All this is exponential, this is the base, and this is the power. Okay? So now, whenever you have, let's say A power B times, dot and times the same thing. And then A power Y. So you see these bases are the same. So if these bases are the same and the power is different and then there's a multiplication, what you do, you write only one base. So you say A and then add this power, add the power B plus Y. Only when the bases are the same, like 3x times 3, 2 plus C. So, the bases are the same, so I don't have to write them 2. You don't only write one base. So I'm going to write only one base because they're the same and it must be multiplication. And then you add the power. So the power is going to be x plus 2 plus c. Oh, that's how we do. Hey, that's how we do. Only when the bases are the same. You know what I'm saying? Now, another one, you might have a division. So the bases are the same, only work for multiplication and division. For example, somebody say 9x over 3t. Whew. The base is not the same now. What I'm going to do? But a 9 I can break it. So this 9 is going to be 3. 9 is 3 squared. Means 3 times 3 equal to 9. But I have an x here. There's an x. So, and then over 3 and t. The bases are the same. So the bases are the same. And since the bases are the same, take the top minus the bottom if it's division. You see division. Make sure you take the top minus the bottom. So since the bases are the same, I'm only going to write one base because they're the same. And I'll take the top minus the power of the denominator. So remember, if it's division, take top minus the bottom power. But if it's multiplication, add the both power. The top power because the both top. So now, let's come here now for the first question. Can you apply here? No. You know why? Because the bases are not the same, even though there's a multiplication, but the bases are not the same. You know what I'm saying? The bases are not the same, so I'm going to write the bases are not the same. So for that case, that's not true. You know what I'm saying? Because x power 3 times y power 3, there's nothing you can do because the law does not apply. The law only applies when the bases are the same. Like if it was x power 3 times y power times x power 3 again, or x power 2, whatever, x power 3, and I was going to write only one base. 3 plus 3 equal to 6. You add the power, don't multiply the power, okay, when the bases are the same. So this one there's nothing can do. So now excuse me. So now x power 3 times y power 3, it remains the same the way how it is because the law does not apply. So this is a lie. You know what I'm saying? That's it. Lie is not true. Okay, so it remains the way how it is. And another way that I can prove to you is not true, shows me. Let's do this. Let's say x equal to any number. Let's say x equal to 1 and y equal to, let's say y equal to 2. Let's take this value and plug it in here. And then let's plug this value on the right hand side to see if left hand side equal to the right hand side. X equal to 1, so it's going to be 1 cube. And then multiply. Y equal to 2, so it's going to be 2 what cube. Okay, now let's see if it's going to be equal to the right hand side. So we're going to put the bracket. What is our x? Our x equal to 1. So I'm going to say 1 plus. What is our y? Y equal to is a 2. Number 2. And then we have what? Power 5, power 5. Now let's see. 1 power cube, 1 times 1 times 1 equal to 1 times. 2 cube means 2 times 2 times 2, which equal to 8. Okay, now when you say 2 cube, it's like 2 times 2 times 2. Means 2 times itself times itself. Okay, now 1 plus 2 equal to 3. 3 power 5. Oh, so 1 times 8 is 8, and this is 3 power 5. It's already not true, because if you take 3 power 5, it's like saying 3 times 3 times 3 times 3 times 3. And there's no way it's going to be equal to 8, so it's not equal to 8. So the first one is not true. Now we go for the second one. Oh, ha 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 ha. And the second one is true, man. I mean, we see, because the base are the same. So I'm only going to write one base, and then I'm going to add the power. 2 plus 3 equal to 5. So this is true. Now we go for the next. How? No, it's not true. The next one is not true. It's not even the rule like that. We don't have a rule, such a rule like that. Because mathematics is a rule. So you're going to have to follow the rules. Excuse me. So now there's no this such a rule. Okay? If somebody say, let's say x power 3 plus y power 2 is not true, that you have to put them in a bracket and then add the power, you say 5. No, there's no such a rule. We didn't learn this. I just show you now. We don't have such a rule. It's not true. Okay? So just so you know, there's no such a rule. Mathematics is a rule, so make sure you follow the rule. Okay? You don't do how you want. And I can disprove this. Look, let's say x equal to 2. So it's going to be 2 power cube plus. Let's say y equal to any number. Let's say 1. So we choose x equal to 2 and y equal to 1. So it's going to be 1 square equal to, what is x? We say x equal to 2 plus, what is a y? Y equal to 1 power 5. Now we go, 2 cube means 2 times 2 times 2 equal to 8 plus 1 square is like 1 times 1 equal to 1. Now let's see right hand side. 2 plus 1 equal to 3 power 5. Now this is equal to 9. 9 is not equal to 3 times 3 times 3 times 3. It's not true. You know what I'm saying? So it's not equal. Because if you multiply 3 times 3 is already 9. 9 times 3, 27. 27 times 3, 81. 81. 81 times 3, 243. It's not true. You know what I'm saying? So 9 is not equal to 243, 243. So this is not true. What about this one? There's no such a thing. It don't even make sense. Some rubbish. I'm sorry to say that, but this is trash. It's not even, make no sense. They say x squared times y squared equal to x power 1, 0. What the hell is that? Crap, this is rubbish. Rubbish, I'm sorry. That's a rubbish, man. So we go question number 2. Number 2, we're going to use the same approach, man. So which approach? Please, don't call me sir. I'm not sir, okay? You can call me Hamish, or sometime Hamish for my official name, my birth name. You know what I'm saying? But you can call me 25 Bacteria for my music. You don't know what about call me sir. You can just call me Hamish if you too professional. But if you young, you know what I'm saying, you can call me Bacteria. 25 Bacteria. Now let's do this question. This is very easy. So we're going to do the same approach. Look, there is a multiplication, and I see this letter, everywhere there's a multiplication. X squared times y times z times y times z. Now look, this is x squared and this x cubed. Okay, and there's a multiplication. So what I'm going to do, I can do straight away here. What I'm going to do, I'll say these bases are the same and there's a multiplication. So I'll say x squared and x cubed. I'm going to write only one x. Add the power 2 plus 3 equal to 5. Now we go for y. There's no power, but look. If somebody say 5 and 5 power 1 is the same thing. You know why? 5 is 5 and 5 power 1 means 5 times the same thing. Excuse me, means 5 times 1, which equal to 5. So if somebody say k and if somebody say k power 1 is the same thing. If somebody say m and m power 1 is the same thing. So since there's no power here, I'm going to say, let me put this in the power 1. And there's no power here, so I'll say z power 1. Why do I do it? Because I know these and these, they're similar. So I'm going to bind them together and write only one base and add the power. So say z, because y doesn't have a friend here, only z. So I'm going to write only one z, okay? Now, and there's a z here, so I don't have to write them 2 because bases are the same. So say 1 plus 5 equal to 6. Oh, so y doesn't have any friend, so I'll just write what? Y, but its power 1, and then we over and make a space. You know what I'm saying? and then over, we do the same thing at the denominator. But denominator, let's write it how it is. It's just what? X power 5, and then we have a Y. Since there's no power, I'm going to put power 1, and then have a Z power 4. Oh, so now how are we going to do now? We're going to do the same game. You know what I'm saying? But now it's going to be in division, because now at the denominator we don't have no more x. At the denominator we don't have no like x with the x. So now we're going to go as a division. You know, so we say division when bases are the same. Like look, their bases are the same. So I'm going to write only 1, and I'll take the numerator minus denominator because they have the same base. So say 5 minus 5 equal to 0. Now I go for z. This z and this z, so they have the same base. I'm going to write only one z. I take the numerator, which is 6. You must take top power minus the bottom. 6 minus 4 equal to 2. And then you go for y. So it's going to be y, 1 minus 1 equal to 0. But remember, any number power 0 equal to 1. You see me right here? If you put me power 0, I'm equal to 1. All you guys watching me, right? I don't know how many of you. 1 million, 1 trillion, you know what I'm saying? Put power 0 equal to 1. So if I say, you see this, all this blackboard, let me say this, you know what I'm saying? You see all this stuff, put power 0 equal to 1. If you say MT4 bracket power 0 equal to 1. 4,000 million power 0 equal to 1. Oh, so x power 0 equal to 1 times z square times y power 0 equal to 1. So 1 times z square times 1 equal to z square. What you mean? 1 times anything, that's something. So 1 times z square equal to z square. So now, so this is the option 4. Option 4, you know what I'm saying? And for this question here is option 2. But for this is option 4. So here is option 2. And this is option 4. Okay, now let's go for the last question. You know what I'm saying? So we'll go for the last question. I'll make a space. I want to resound the party here. We'll go for the last question. Okay, cool. No problem, man. So, you know how we do? Decision guarantee. We don't waste no time, okay? Now, let's do this. This is very easy. So, first and foremost, what I'm going to do, you know BODMAS. We're going to have to play with BODMAS here. BODMAS. Start with the bracket, division, multiplication, addition, subtraction. So, now, before I do anything, you know what I'm going to focus on? These under bracket. Because you got bracket. Let me focus on this bracket and everything under, like these under root. I don't need them, this under root. Here's multiply 10 times. Like, let me get rid of this. Okay, now we go. 8 power cube. If you have a calculator, scientific calculator, you can plug in the how it is. But you know, cube root of 8 is 2. Means cube root of 8 is like which number times which number times which number. I'm gonna get 8. Means cube root. You know what I'm saying? Means number times number times number is gonna give me. That's what I say cube root. It's like you reverse the cube root. So it's equal to 2. So here it's going to be equal to 2. Now we go multiply. So I'm not going to write this anymore. It's 2 times 3 square. 3 square is like 3. Y square means y times y. T cube means it's t times t times t. So 3 square means 3 times 3 equal to 9. Now we go plus. So you got big root here. Like I said, it started with the inner one, okay? Bracket. Oh, I got my bracket. 25 plus 15 equal to 40. So this is going to give me 40. And then I got division here. Now we go. Let me deal with the root here. So 6 square means 6 times 6 equal to 32. So it is 32, but there's a root inside. Minus 11. Oh, 32 minus 11 equal to 21. Oh, 21, really? Oh, yeah. You know what I'm saying? 32 equal to 21. Oh, so now we got 6 square means, oh my goodness, what am I doing? You forgot the time table? My teacher, I'm gonna be so embarrassed if my teacher watch me what I'm doing. 6 times 6 is 32. Don't do that. Sure. So now 6 times 6 equals 36. So this is 36. So 36 minus 11 equal to 25, but we still have a root. But a square root of 25 equal to 5. Oh, so all this stuff here equal to 5. Okay, so it's going to be divide by 10 times all this stuff will give us what? 5. Okay, so now the next thing is BODMAS. So let me deal with this. I still have an outer root. Outer root. So now we go. Okay, brackets are gone. Division. Oh yeah, I have division. So I'm going to have to start the division. 40 divided by 10 equal to 4. And they have multiplied by 5. And they have a root. And they have a 2 times 9. And then we have a plus. You know what I'm saying? Now we go. Okay, so now 4 times 5 equal to 20. Square root of 20. And they have a plus 9 times 2. 2 times 9 equal to 18. Plus square root of 20. Okay? You know what I'm saying? And then you go square root of 20. I think I made a mistake because there's no option here. So I made a mistake somewhere, and I believe you might be laughing at me right now, like, oh, you made a mistake right there, can't you see? You see, you might be laughing at me. So I hope you don't mind, let me check where I made a mistake. So first and foremost, I started here, I say square root of 8 equal to 2. Yeah, it's 2 equal to 2. Now we come here, times. 3 squared equal to 9, Yes, I agree. Plus, now we come here inside. Now I started with a root now. 6 squared equal to 36 minus 11 equal to 25. Square root of 25 equal to 5. Oh yeah, 5. And I have a times, we have a times. We have a 10, we have a 10. We have divide, we have divide. 25 plus 15. 25 plus 15 equal to 40. 40. Oh yes, I feel like I did correct this question, man. Now we go. So BODMAS, bracket no division. Oh yes, I have division. 40 divided by 10 equal to 4. And I have multiplied by 5 equal to 20. So 2 times 9 equal to 18 plus 20. So now we say plus. Okay, so now 20 is 5 times 4. And then we have a root, and then I have a 18. But I can separate mathematically if you have a root. So say square root of 4 times square root of 5 is acceptable. 18. Square root of 4 equal to 2 plus 18 times square root of 5. Because square root of 4 equal to 2. This is going to give us 20 times square root of 5. Oh, so 20 times square root of 5, there is no option. Where do I make mistake? Okay, one more time, okay? You walk with me. We want to see what we make mistake, you know what I'm saying? So now we say, okay, now let's get started. So we say 6 squared, 36, minus 11, 25, square root of 25 equal to 5. Yes, it's 5. And then I remove this. I wrote 5, yes, it's 5. Now we go multiply. Is it multiply there? Oh, yes, multiply. 10, 10. Now, 25 plus 15. Grade 1, 25 plus 15. 40, yeah, of course, it's 40, man. And they have a square root. Now we have a 2, that one, because square root of, cube root of 8 equal to 2, and that equal to 9. 40 divided by 10 equal to 4. Really, 40 divided by 10? 40 divided by 10, 0, 0 cancel, this equals 4. Oh yes, 4. So I wrote 4 here instead of 10 divided by 10. Multiple 5, 20. 4 times 5 equals 20 plus 18 plus 20. Oh, there's no option, so I'm gonna have to do it again. I didn't get this one right, I'm so sad. I'm gonna do it again, don't worry about it, man.